Hi everyone, welcome to my YouTube channel City of Electrons, and in this video we'll be talking about induction motors, of course as part of the series class recap. And then this course is electrical machines too. So talking about induction motors. Now, induction motor is a type of AC motor, okay, and what it does is convert electrical energy to mechanical energy, and it does this using alternating current. So of course this induction motor is a class of AC motor, okay, and so this is an image of the induction motor, induction motor how it looks like in real life. Okay, so being that induction motor is a type or class of AC motor, it's also important we know the classes of, or how how AC motors are classified. So here we have it. AC motors are classified based on the following. So they are classified based on their principle of operation. That's one of it. Then another classification of AC motor is based on the type of current. Another one is based on their speed, and then the last one is based on their physical features. That's how they look like. Okay. Then of course AC motor is an electric motor that uses alternating current to convert electrical energy to mechanical energy. Generally, motors convert electrical to mechanical. Then generators convert from mechanical to electrical. So for induction motor, or for AC electric motor, they do the conversion from electric to mechanical using AC, alternating current. Right? Then for the general principle of an induction motor, it works as, there's a general rule. Okay, there's a general rule that the conversion of electric power into mechanical power takes place in the rotating parts of an electric motor. Yeah, it takes place in the rotating parts. So this conversion of power, that rotating part of the electric motor, that is where the conversion takes place. Okay, of course as a general rule. Then in DC motor, this electric power is conducted directly to the armature. That's the rotating part, of course. So for DC motor, that power is conducted. When we say conducted, of course, we mean there is physical contact, okay, to the armature, which is the rotating part. Okay, and this is done through the brushes and commutator. Okay, then since that is done in DC motor, hence in this sense a DC motor can be called conduction motor. That's because for induction motor it is done without physical contact. It is done based on induction. Current or the power here is induced without physical contact. That's for induction motor. But AC motor, there is physical contact through the brushes and commutator. So in this sense, we can truly say for DC motor, it is a conduction motor because there is physical contact through brushes and commutator. However, okay, from this part now. However, in AC motor, the rotor does not receive electric power by conduction, but by induction, in exactly the same way as the secondary of a two-winding transformer receives its power from the primary. Alright, so that's why such motors are known as induction motor. So just like a transformer, the secondary part and the primary parts, they don't make like physical contact. Power is moved from one part to the other part through induction, not conduction. Conduction, contact; induction, no contact. So it's almost like saying the induction motor is like a transformer, like the primary and the secondary of a transformer. From the next paragraph here, in fact, an induction motor can be treated as a rotating transformer, just like we compare it to a transformer, saying one part is the primary part and the other part is the secondary part, because a transformer does its power conversion from one part to the other part through induction. An induction motor does the same, but induction motor has a rotating part and a stationary part. So we can, that's why here it said, we say that an induction motor can be treated as a rotating transformer. That is one in which primary winding is stationary, but the secondary winding is free to rotate. The primary winding here we refer to the stator, which is stationary, and in the secondary winding we refer to the rotor, which rotates. But of course, winding has to do with transformer, both parts, primary winding and secondary winding. But for the induction motor, we have the stator considered as the primary part, and then the rotor considered as the secondary part. Okay, so that's why, and I think this is one of the reasons why in the formula, when making calculations, the rotor part is denoted with 2, then the stator part is denoted with 1. I've seen that in our calculations. I've seen that, like anything rotor in the formula or calculation, you see 2 under it, like E2 and flux 2, just like that. So yeah, then in our next okay, so this is just it for this video. Okay, just simple introduction to induction motor. Simple introduction to induction motor. Yes, yeah, that's it. So yep, this is it. Induction motor, type of AC motor that converts electrical energy to mechanical energy by using alternating current, and it's a picture of it. And then we have the classification of induction motor. The classification of AC motors as regard the principle of operation, as regard the type of current, as regard the speed, and as regard their physical features. Okay, and then we also talked about the general principle of induction motor. And in the next video, we'll talk about the construction of an induction motor. So this will be all in this for this video. And then leave comments in the comment section if you have any comments or have any question or anything in the comments, and share, like, subscribe, click on the notification bell, and I'll see you in the next video. Thanks for watching, and bye for now.